What is linear programming? Linear programming is a mathematical modeling in which a mathematical function is either minimized or maximized when subject to constraints. So, in the Second World War era, it was used to solve problems of food distribution, medicine, and the likes. Now, every linear programming problem has two components. The first part is a linear objective function. So every linear programming has a linear objective function. And then the second component is a collection of linear inequalities that must be satisfied simultaneously. So a collection of linear inequalities. So these are the two components of a linear programming problem. So this portion is what leads to what we call the objective function. That is the linear objective function. So it is the objective function. And that is actually what is minimized, the function that is minimized or maximized. And then there are the constraints. The constraints is what determines the extent to which the objective function is minimized or maximized. So normally the objective function is of the form, for example, z equals ax plus by. The objective function is always in this form. It is what is minimized or maximized in a linear programming problem. Then the constraint normally comes in with inequalities, with either less than, greater than, less than or equal to, or greater than or equal to. Those are what is these are the nature of at which the constraint normally can. The point that satisfies a system of constraints is called a feasible point. So normally, after sketching your problem, you normally find the required area or the feasible point. That is the point that satisfies a system of linear inequalities. And those system of linear inequalities are also called the constraints. So let us graph the following constraints. For example, if we have A given as 3x plus 2y greater or equal to 6, and then we have B which is given as 2y minus x minus 3 less than 0. How will these constraints look like on the graph? So let us graph these constraints and then find a feasible point. Now, what we normally do in linear programming problems is to find the x and y intercept. So we know that for the y-intercept, x is equal to 0. So let's solve the a part. That is 3x plus 2y is greater or equal to 6. So first, let's find the x-intercept. Sorry, the y-intercept. For the y-intercept, x is equal to 0. So let's put x equals 0 in this function. We are going to get 3 times 0 plus 2y is greater or equal to 6. So 0. So if we divide through by 2y, we will come in. So 3 times 0 is 0. So we'll be left with 2y greater or equal to 6. So let's divide through by 2. Y is greater or equal to 3. So we have 1 point, and that point is the x component is 0 and the y component is 3. Then now let us also find the y-intercept. the x-intercept, and for the x-intercept y equals 0. So let's put y equals 0 into this equation. We will get 3x plus 2 times 0 is greater or equal to 6. So we get 3x is greater or equal to 6. So when we divide through by 3, we'll get x is greater or equal to 2. So we have the point. Okay, so we found the x component. Let's find the y. So we have the point 2 and 0. So you see that the y-intercept is 0, 3, and then the x-intercept is 2, 0. So having found these two, we can then draw the straight line between these 2 points and find the feasible area. So let's sketch it on a graph and then find the feasible area. So this is how our Cartesian plane looks like. So now let's plot the point 0, 3 and 2, 0 on our graph. So 0, 3, so this is the origin 0. So 0 on the x-axis and 3 on the y-axis. So this is the point 0, 3. So we have this point which is 0, 3. And then we have also the point 2, 0. So 2 on the x-axis, 0 on the y-axis is this point. So this point 2 is 2, 0. So what we need to do is to draw a straight line to connect the 2 points. Alright, so this is our straight line that connects the 2 points. Now, always when you draw the straight line, you must write the equation of the line. And then the equation of the line is this equation, which is 3x plus 2y is greater or equal to 6. So, having written that, then now let's find the feasible point. So, what we will do is that we will take points below the line and then above the line, and then we'll test. So you see that we can find this point, which is 1, 1, inside below the line. So let's put 1, 1 inside this equation and see whether the equation is defined. So 3 times, so let's prove it somewhere here. So it is 3x plus 2y is greater or equal to 6. So we are using the point 1, 1. So wherever we see x, we put 1. And wherever we see y, we also put 1. So this becomes 3 times 1 plus 2 times 1. 3 times 1 is 3 plus 2 times 1. That will give us 5. So, but then 5 is not greater than or equal to 6. And therefore, this side, the points below the line is not the feasible point. So if that is not the feasible point, then there is only one point left, which is all the points above the line. But then let's still prove that that is correct. See that when you look at here, you can find that the point 2, 2 is above the line. So let's put 2, 2 into this equation. So let's put 2, 2. So you see that it will be 3 times 2 plus 2 times 2. 3 times 2 is 6. Then 2 times 2 is 4. 6 plus 4 is 10. So this is equal to 10. And 10 is greater or equal to 6. So that makes this inequality true. So we will need to shade the region of the feasible point. So let's shade. This is the graph showing 3x plus 2y greater or equal to 6 with the feasible region. Second part of the question is 2y minus x minus 3 less than 0. So as usual, just as we do, we need to find the x and y intercept. So let's find the y intercept. For the y intercept, x is equal to 0. So this becomes 2y minus 0 minus 3 is less than 0. So we'll get 2y, then we'll bring 3 to the other side, it's less than 3. So let's divide through by 2. So we get y less than 3 over 2. Then now let's find the x-intercept. And for the x-intercept, y equals 0. So let's put y equals 0 into the inequality. And that will give us 2 times 0 minus x minus 3 is less than 0. So minus x is less than minus 3. So let's divide through by minus 1. But remember that anytime you divide an inequality by a negative number or you multiply by a negative number, you have to change the sign. And therefore x is greater than, here is 3. But if we take this 3 to this side, it will be 3. So it will be x is greater than minus 3. So this is the line 2y minus x minus 3 is less than 0. Now the next thing is to find the required region. So let's take a point that is below the line and a point that is above the line. So let's choose the point. If we look here, we see that this point 0, 1 falls below the line. So let's put 0, 1 into the equation. The equation is 2y minus x minus 3 is less than 0. So let's put 0 and 1 into the equation. So we'll get 2 times 1 minus 0 minus 3 is less than 0. So you see that 2 times 1 is 2, minus 3 will give us minus 1. So minus 1 is less than 0, and that is true. And therefore that makes this region the feasible region. Now let's try a point above the straight line. So let's take the point minus 3 and probably 3 and see whether it will satisfy this inequality. So 2 times minus 3 minus 3, 2 times minus 3, 2 times 3 rather, because we are taking the point 3 minus 3 and 3. So 2 times 3 minus the x value is minus 3. So minus 3 minus 3 is less than 0. So this becomes minus 3 becomes plus 3. 3 minus 3 is 0. Now 2 times 3 is 6. But 6 is not less than 0, and therefore the region above the line is not the required solution. The only region that is the required solution is the region below the straight line. So let's shade the required. So this is the graph of the required region. Indicate by shading the set of all points in the OX y plane that satisfies simultaneously the inequalities 2x plus y greater or equal to 3, x greater or equal to y, 2y minus 1 greater or equal to 0, and then x less than or equal to 4. So what we must do in this case is that let's take the first inequality, which is 2x plus y greater or equal to 0, greater or equal to 3. So what we will then do is that we need to find the x and y intercept. So for the x-intercept, y is 0. So let's put y equals 0 into this equation. This becomes 2x plus 0 greater or equal to 3. So 2x is greater or equal to 3. If we divide through by 2, and we divide here 2 by 2, then x is greater or equal to 3 over 2. So now we have the point Let me start it from here. We have the point y is 0 and x is 3 over 2. So we have the point 3 over 2 and 0. So what we then we must do again is to find the x-intercept. And for what we must do again is to find the y-intercept. And for the y-intercept, x is 0. So let's put 0 into this equation. So what about x equals 0? The equation is 2x plus y greater or equal to 3. So let's put x equals 0 here. So it becomes 2 times 0 plus y is greater or equal to 3. So y is greater or equal to 3 because 2 times 0 is 0. So we have the point 0 and 3 also on this line. So we are done with this inequality. The next inequality is this one. So let's take x is greater or equal to y. So let's put x equals 0 into this inequality. If x is equal to 0, then y is less than or equal to 0. So we have the point 0, 0 on this graph, on this line. So let's put if we put y equals 0 into this inequality, it will give us 0 back to 0, 0. So let's change. Let's put y equals 2. So if we put y equals 2 into this inequality, x is greater or equal to 2. So that means that we have another point 2, 2 on this inequality. So we are done with this inequality. Let's take this one as well. And the inequality is 2y minus 1 is greater or equal to 0. So let's solve it. This becomes 2y is greater or equal to, we are taking minus 1 to this side. That is 1. So dividing through by 2, we see that y is greater or equal to 1 over 2. So we have the line y is greater than or equal to 1 over 2. At this point, x is 0. So we have this point which is 0 and 1 over 2 also as one of the coordinates on this inequality. Then we have this inequality which is x is less than or equal to 4. So at this point where x is less than or equal to 4, y is equal to 0. So we have the coordinate 4 and 0 also on this inequality. So having found the various coordinates, we shall then go ahead to sketch the graph. So if you look, let me write the sets of points here. We have 3 over 2 and then 0. We also have 0. So this one goes along with 0, 3. Then we also have this one which is 0, 0. And then we also have 2, 2. Then we also have this inequality which is y is greater or equal to 1 over 2 and x is less than or equal to 1 over 2. So we have these points which are 0, 1 over 2, and we also have the last one which is 4, 0. So let's then sketch our graph and then plot the points. So assuming this is our graph in the OXY plane, let us go ahead and plot the points 3 over 2 and 0. Now 3 over 2 is 1.5. So let's plot the point 1.5 which is somewhere here, and then 0 on the y-axis. So this point is somewhere here, And then we also have this point, which is 0, 3. So 0 on the x-axis and then 3 on the y-axis. So this point will be somewhere here. So let's then join both lines. Let's then join both points to form a straight line. And this line it corresponds to the inequality 2x plus y is greater or equal to 3. Now let's go ahead and then plot the second point, which is 0, 0 and 2, 2. This is the coordinate for 0, 0, and then 2, 2, 2 on the x-axis, and then 2 on the y-axis is going to be somewhere here. This is 2, and then 2 on the x-axis and 2 on the y-axis. So this point is going to lie somewhere here. So let's join both points to also form a straight line. So this line too is the equation, which is this one: x is greater or equal to y. Now let's draw the line y is greater or equal to half. So this is 0, this is 1. So between 0 and 1 will give us 0.5. So somewhere here. So this is the line y is greater or equal to 1 over 2. Then now let's plot the last one, which is x less than or equal to 4. So it's going to be here. So this is the line x less than or equal to 4. So this is how our graph is going to look like. But then from the question, it says that we should indicate by shading the set of all points in the OXY plane that satisfies the inequalities. So we are now going to indicate the required region in this graph. Now let's come and choose the point. You see that if we choose this point 3, 3, let's try this point. This is 3. Okay, let's choose the point 2, 1, which is in this region. We want to test whether this region is the required region. So 2, 1 is going to give us somewhere here in this region. So the point 2, 1 is in this region. So let's try the 2, 1 and see. Now let's take this inequality. The inequality is 2x plus y is greater or equal to 3. Now we are using the point 2 on the x-axis and then 1 on the y-axis. So we are going to put 2 here. Wherever we see x, we put 2, and wherever we see y, we put 1. So it becomes 2 times 2 plus 1. 2 times 2 is 4. 4 plus 1 is 5. And 5 is greater than 3. So it satisfies this inequality. Let's come to this inequality. X is greater or equal to y. X is greater than or equal to y. So the inequality is 2, 1. Now 2 is greater or equal to 1. That is true. So it also satisfies this inequality. Let's come to this inequality. 2y minus 1 is greater than or equal to 0. So 2y minus 1 greater or equal to 0. The y component is 1. So it becomes 2 times 1 minus 1 greater or equal to 0. 2 times 1 is 2. 2 minus 1 will give us 1. So 1 is greater or equal to 0. That is true. So it also satisfies this inequality. And then the last one is x is less than or equal to 4. What is the x value? The x value is 2. So 2 is less than or equal to 4. It also satisfies this inequality. So you see that the required region is this region. because it is this region that all the points here satisfies all four inequalities. So that is the region we must shade. So by our answer, this becomes the required region of this set of inequalities. So this is the required region. Indicate by shading the set of all points P, X, Y in the OXY plane that satisfies simultaneously the inequalities 2x minus y plus 4 greater or equal to 0, x plus y less than or equal to 10, y minus x greater than or equal to 0, y greater or equal to 2, there's a 2 here, and x greater or equal to 0. And the second part is use your diagram to find the values of x and y for which 10x plus y is maximum. So let's start with the first inequality. So these inequalities are the constraints, and then this is the objective function. So the objective function is I equals 10x plus 5y. Now let's take this inequality or the first constraint, and that is x plus y is less than or equal to 10. So what we'll do is that we'll find the x and y intercept. For the x-intercept, y is equal to 0. And then if we put y equals 0 into this inequality, you see that x plus 0 is less than or equal to 10. So x is less than or equal to 10. So let me continue from this side. So you see that we have the point 10, 0 on this constraint. And the next thing is let's find the y-intercept. For the y-intercept, x is equal to 0. So let's put x equals 0 in the inequality. We then have 0 plus y is less than or equal to 10. So y is less than or equal to 10. And therefore, we also have the point 0, 10 on the inequality. So we are done with the first constraint. Let's come to this constraint. This constraint is y minus x is greater than or equal to 0. So let's send x to the other side of the equation. So I'm bringing x here. So this becomes y is greater or equal to x. So let's set x equals 0. If x is equal to 0, y is greater or equal to 0. And therefore we have the point 0, 0. Now let's also set the point y equals 2 into, let's set the point y equals 5 into the constraint. So if we put y equals 5 here, you see that x is less than or equal to 5. And therefore we also have the point 5, 5 on that constraint. So the next one is the line y is greater than or equal to 2 and the line x is greater than or equal to 0. So let me write down the points, the coordinates, and then we are good to go. So the first coordinate is 10, 0 and then 0, 10. Then the second one we add 0, 0 and 5, 5. 0, 0 and then 5, 5. Then the next one we have this line which is y is greater or equal to 2, y equals to 2 and x greater or equal to 0, which is the same as the x-axis. So let's then sketch the graph. This is how we begin the graph. Now let's go ahead and then plot the points. So the first one is 10, 0 and 0, 10. So let's plot 10, 0. That is 10 on the x-axis and 0 on the y-axis is this. And then 0, 10. 0 on the x-axis and then 10 on the y-axis is this point. So let's join the 2 points. So this is the line x plus y less than or equal to 10. So x plus y less than or equal to 10. Then now the next one is 0, 0 and 5, 5. So this is 0, 0. Now let's sketch 5, 5. So this is 5, 5. So let's join the 2 points. So this line is the line y minus x greater or equal to 0. The next one is the line y is greater or equal to 2, which is this. So this is the line y is greater or equal to 2. But there is an important constraint that we forgot about, and that is 2x minus y plus 4 is greater or equal to 0. We forgot, there's a mistake, so we forgot about this constraint. Let's then go ahead and find the x and y intercept for this constraint. So let's write the inequality well. It becomes 2x minus y is greater or equal to, I'm taking 4 to this side, so that becomes minus 4. So let's put x equals 0 into the inequality. We will then have minus y greater or equal to minus 4. So y is greater or equal to 4. And therefore, one of the coordinates are 0, 4. And then let's put y equals 0. If we put y equals 0 here, we'll get 2x is equal to, is greater or equal to, let me write it well. If we put y equals 0 here, we'll get 2x is greater or equal to minus 4. So let's divide through by 2. So x minus 2. And therefore, we also have the point, which is minus 2 and then 0. So the set of coordinates for this inequality is, the first coordinate is 0, 4, and we also have the second coordinate minus 2 and 0. So since we have minus 2, I'm going to extend the graph a little to the negative region. So this becomes our coordinate minus 1 and then minus 2 on the x-axis. So let's plot the points. We have the point 0, 4. So 0 on the x-axis and then 4 on the y-axis is this point. And we also have the point negative 2, 0, which is negative 2, 0. So let's then go ahead and then join these two lines. So this is how the graph is going to look like. So this line is the line 2x minus y plus 4 is greater or equal to 0. So the next thing is to find the required region. So let's find the required region for this graph. So let's take a point somewhere here. You see that if we take the point 2, 4, 2, 4 is somewhere here. So that's this whole region. Let's then go ahead and test 2, 4 with the constraints that were given. So let me start from those at the bottom. So the point is 2 on the x-axis, then 4 on the y-axis. So x is greater or equal to 0, and then x is 2. So 2 is greater or equal to 0. That is true. So the point passes for this constraint. Then y is greater or equal to 2, and then the value of y is 4. 4 is greater or equal to 2. That is also true. So the point also passes for this constraint. Now we have y minus x is greater or equal to 0. The value of y is 4 minus the value of x is 2. is greater or equal to 0. 4 minus 2 is 2. And it is true that 2 is greater or equal to 0. It also passes for this constraint. And the next one is x plus y is less than or equal to 10. X is 2 and y is 4. Let's find 2 plus 4. It is equal to 6. And 6 is less than or equal to 10. And that is true. It also passes for this constraint. The last one is 2x minus y plus 4 is greater or equal to 0. So 2 times the value of x is 2 minus 4, that's the value of y, plus 4 is greater or equal to 0. Minus 4 plus 4 is 0. 2 times 2 is 4. And it is true that 4 is greater or equal to 0. And therefore this point also passes this constraint. And therefore you can see that the required region is this region. This is the required region for this graph. Now, in the second part of the question, it says that we should use our diagram to find the objective function 10x plus 5y. The values of x and y for which the objective function I equals 10x plus 5y is maximum. So what we will do is that we will then go ahead and label these points, because these are the points that set the boundaries for this required region. So let's start labeling. Let me denote here as K, and then here as L, and then this point as M, and then this point 2 as N, and then the last one is O. So this is K, L, M, N, O. These are the points that bound the required region. So let's then go ahead using these points to find the objective function. So what is the point K? K is this point, and this point is 0, 2. And then L is this point, and this point is 0, 4. So L is 0, 4. Then M is this point, which is somewhere 2. You see that if we trace from 2, and then 8, so M is 2, 8. And then N is this point. So you can see that this point is somewhere around 5. Now my graph has not been drawn to scale, and therefore if we do it on the actual graph, you find out that the value of N is 5 on the y-axis and then 5 on the x-axis. So it is 5, 5. And then the value of O, see that O is 2 on the x-axis and then 2 on the y-axis. So the coordinates for O is 2, 2. So what we will then do is that we will take these coordinates of K, L, M, N, and O and then put it in the objective function, and then find the value for which the objective function I equals 10x plus 5y is maximum. So having gotten the various points, what we'll do is that we'll put the various coordinates into this expression and find the values of I. So the first one, K is 0, 2. So I is equal to 10x plus 5y. So I of K is equal to 10, the value of x is 0, plus 5 times the value of y is 2. And if you do this, you are going to get I equals 10. 10 times 0 is 0. 0 plus 5 times 2 is 10. So it will give you 10. And for that matter, here is 10. Then L is 0, 4. So I of L is equal to 0, 4. So it becomes 10 times 0 plus 5 times 4. 10 times 0 is 0 plus 5 times 4 is 20. And this will give us 20. So I of L is 20. Then M is 28. So let me solve M here. I of M is equal to 10 times 2 plus 5 times 8. And then this will give you 60. 10 times 2 is 20. 5 times 8 is 40. 20 plus 40 is 60. So this part is 60. Then I of M, which is 5. So 10 times 5 plus 5 times 5. 10 times 5 is 50 plus 5 times 5 is 25. 50 plus 25 will give you 75. And therefore, this part is 75. And then O is 22. So I of O equals 10 times 2 plus 5 times 2. 10 times 2 is 20 plus 5 times 2 is 10. 20 plus 10 will give you 30. And therefore this part is 30. But we are looking for a point where the objective function is maximum. So we have 10, 20, 60, 75, 30. The maximum value here is 75. And it corresponds to the point N 5. So the maximum point that we're asked to find from the question, let me write it here. The maximum point is the point for which I is maximum, which is 5. So it is 5. A self-employed carpenter earns $10 for the sale of a table and $180 for the sale of a rocking chair. It takes 2 hours to make a table and 5 hours to manufacture a rocking chair. He is limited to working 40 hours per week. The average manufacturing cost is $15 per table and $45 per rocking chair. He wishes to keep his manufacturing cost at $315 per week. How many tables and rocking chairs should he make to maximize his weekly sales? Determine the maximum sales and profit he can make per week. So in this question, you see that we are having 3 different variables. The first one is his income, which is the sales he make. The first one is the sales he make, the sale of a table. And then the second one is the time it takes for him to manufacture. So the next one is time. And then the last one is the cost. So he says that it cost him $15 per table. So we have the sales, the time, and the cost. So let's make a table. But there are only 2 variables, which are what? The tables and then the chair. So he sells a table and he also sells a chair. So let's make a table here. So this is chairs and tables. So chairs and then tables. Then the first one is sales. The second one is the time it takes him. And then the last aspect is the cost involved. So from the question, he says that the carpenter earns $10 for the sale of a table. So let me make a correction here. It is $90. It's not $10. the carpenter earns $90 for the sale of the table. So for the sale of a table, he earns $90. So $90 here. And then $180 for the sale of a rocking chair. So for the chairs, he earns $180. Then now, it takes him 2 hours to make a table. So the table is 2 hours. And then 5 hours to make a rocking chair. So the chair is 5 hours. Then the question also says he's limited to working 40 hours per week. The average manufacturing cost is $15 per table. So when it comes to table, it is $15. And then $45 per rocking chair. So the chair is $45. So now, having found this, we can then go ahead to write the function, the inequality, the constraints. So we are using T for tables and then C for chairs. So what are the constraints? The first one is the time it takes him. It takes him 5 hours to manufacture a rocking chair. And then it takes him 2 hours to manufacture a table. So this means that 2T plus 5C, 5 hours to manufacture a chair. Then he is limited to 40 hours per week. So that means it is less than or equal to 40 hours. So this is the first constraint. Now, let's write the second constraint. He says that the average manufacturing cost of a table is $15. So we have 15T, then $45, and $45 per rocking chair, so plus 45C. Then he wishes to keep his manufacturing cost at $315. So that means that it must not be greater than $315. So this is the second constraint. So we've written the constraint. What is the objective function? If you look at the question, it says that determine the maximum sales and profit he can make per week. So the objective function is about the sales. However, he earns $180 for the sale of a chair and then $90 for the sale of a table. So it means that 90T plus $180 per chair is the objective function, and therefore I is equal to 90T plus 180C. Let's go ahead and find the x and y intercept of the various constraints and then sketch it on a graph. So we have 2T plus 5C is less than. So let's put T equals 0. So this becomes 2 times 0 plus 5C is less than or equal to 40. So 5C is less than or equal to 40. And therefore, if you divide through by 5, you see that C is less than or equal to 8. So we have the coordinates 0 and 8. And then now let's set C equals 0. So C equals 0. We will have 2T plus 5 times 0 because it's less than or equal to 40. So 2T is less than or equal to 5 times 0 is 0, so it's less than or equal to 40. So if we divide through by T, 2, these 2 and these 2 cancel, so T is less than or equal to 20. So we are done with this constraint. Let's take the second constraint, which is 15T plus 45c is less than or equal to 315. So we'll get, let's set t equals 0. So it becomes 15 times 0 plus 45. There's 45t. 45t is less than or equal to 315. So if we divide through by 45, we find out that t is equal to 21. So we have the point 0 and 21. Sorry, we have the point 21 and 0. So let me continue the last one from here. Let's come to this point. So now we are going to set, this is 45c. Let's correct this mistake. It's 15t plus 45c. So let me write down the points that we have. We have the first point, which is 0, 8 and 20, 0. And the second point, we have, and the second coordinates are 0, 7 and then 21, 0. So this is 0. So now let's plot the point 0, 8. This is 0, 8 and then 20, 0. This is 20, 0. So let's join the two lines together. And this is for the constraint 2t plus 5c is less than or equal to 40. Now let's come to this side, which is 0, 7. This is 0, 7 and the next one is 21, 0. So this one too is 21, 0. So let's join the 2 points. So having joined the 2 points, this is the line for the constraint 15t plus 45c is less than or equal to 315. So let's then find the required region. Now let's take a point here. Let's say 5, 5. The point 5, 5 will be in this region because 5 is less than 20. 5 is also less than 7. So 5, 5 will be in this region. So the inequalities are 2t plus 5c is less than or equal to 40, and also 15t plus 45c is less than or equal to 315. So using 5, 5 as a point, so 2 times 5 plus 5 times 5. 2 times 5 is 10. This is less than or equal to 40. 2 times 5 is 10. Then 5 times 5 is 25. 10 plus 25 will give us 35. And it is true that 35 is less than or equal to 40. So it satisfies this inequality. Let's also take this one. 15 times 5 plus 45 times 5 is less than or equal to 315. 15 times 5 is 75. Then 45 times 5 is 225. 225 plus 75 will give us 300. And it is true that 300 is less than or equal to 315. So that point also satisfies this inequality. And therefore, the required region is this region that is bound by the following point. So let's then go ahead and then write the point. So let's assume that this is K M. So let's say K L M N. This is what I'm choosing to label my point. So we'll then go ahead and find the coordinates of K, L, and M. So we see that K is 0, 0. L is 20, 0. Then N is 0, 7. Then M. Now, if we, for example, I have sketched my graph, I may not be able to find M. So what I will do is that I have to solve these two equations simultaneously to find the value of T and C. And the value of T and C is where these two lines intersect. So let's find the intersection of these two lines. So the equations are 2T plus 5C is, let me use the equal sign, is equal to 40. So this is equation 1. And we have 15T plus 45C equals 315. Equation 2. So this is 5C and this is 45C. So let's multiply equation 1 by 9. So 2 times 9 is 18. 18T plus 9 times 5 is 45C equals 9 times 40 will give us 360. So this becomes equation 3. And then let's subtract equation 2 from equation 3. So 3 minus 2 to give us 18T minus 15T equals 45 minus 45 is 0. It's equal to 360 minus 315. 18T minus 45T will give us 3T, which is equal to 360 minus 315 is 45. So dividing 2 by 3, we see that T is equal to 15. So we'll then take that value of T equals 15 and put it in, let's say, equation 1, and then find the value of C. And from equation 1, you can see that 2T plus 5C is equal to 40. The value of T is 15, so 2 times 15 plus 5C equals 40. 2 times 15 is 30 plus 5C is equal to 40. So 5C is equal to 40 minus 30. So 5C is equal to 10. And dividing through by 5, you see that C is equal to 2. So this point M is T, and the value of T is 15. And then C, the value of C is 2. So 15, 2. So I is equal to 90T plus 180C. Then now we have our point K is 0, 0. Then we also have our point L, which is 20, 0. Then we have our point M is 15, 2. Then we have our point N, which is 0, 7. So 0, 0, 20, 0, 15, 2, and then 0, 7. So this is for the T values, and these are for the C values. So I, we take 0, 0 and put it in I. So 90, so I of K equals 90 times 0 plus 180 times 0. That will give us 0. Then I of L is 90 times 20 plus 180 times 0, and that will give us 1800. Then I of m equals 90 times 15 plus 180 times 2. And so this is equal to 0. This is equal to 1800, all in dollars. And then this one is $1,710. So this is $1,710. Then I of n, which is 07. T0, so 90 times 0 plus C. 180C is 180 times 7. And that will give us $1,260. So this $1,260. So now the question is asking for the maximum sales and then the maximum profit. So if you see, the maximum sales is $1,800 because this is the maximum value among this four, and therefore the maximum sales is equal to $1,800. Then according to the question, we should also find the maximum profit. I will know that the profit he makes is the sales he makes minus the cost that he incurs in making those tables and chairs. So from what we found that the maximum sales he makes is $1,800. So that's $1,800. And then from the question, he limited his cost to $315. So minus $315. So let me write it well. It is the profit is equal to $1,800 minus $315, and that is equal to $1,485. So this is the maximum profit that he makes.